A warm good morning to one and all. It's my pleasure to welcome everyone to this wonderful webinar on behalf of DG Vaishnav College, Postgraduate and Research Department of Mathematics. Fuzzy logic is an approach to variable processing that allows for multiple values to be processed through the same variable. Fuzzy logic is designed to solve problems by considering all variable and available information and making the best possible decision given the input. Praying is essential for understanding God and for perceiving His existence through our body, mind, and intellect. Now, we begin this webinar by invoking infinity with prayer, Tamil Thai Valthu and College Prayer.
நீராறும் கடலொடுத்த நிலமடந்து எழிலொழுகும் சீராரும் வதனமென திகழ்வரத கண்டமிழே எக்கணமும் அதிசிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை முதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம்பியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
सत्यव्रतं सत्यपरं त्रिसत्यं सत्यस्य योनिं निहितं च सत्ये सत्यस्य सत्यं ऋतसत्यनेत्रं सत्यात्मकं त्वां शरणं प्रपन्नाः वाणी गुणानुकथने श्रवणो कथायां हस्तौ च कर्मसु मनस्तव पादयोर्नः स्मृत्यां शिरस्तव निवास जगत्प्रणामे दृष्टिस्ततां दर्शनेस्तु भवत्तनूनां नमो भगवते तस्मै कृष्णायाद्भुतकर्मणे रूपनामविभेदेन जगत्क्रीडति यो यतः ॐ शान्ति शान्ति शान्तिः.
Feedback form will be posted at end of the session in chat box. The feedback form link will be there up to 2 p.m. today. We issue the certificate only who fill and submit the form within the time. Kindly post your queries in chat box. Classical logic only permits conclusions which either true or false, but fuzzy logic uses degrees of truth as a mathematical model of vagueness, while probability is a mathematical model. Fuzzy logic applications are in fields like decision making, fuzzy querying language, fuzzy set theory, fuzzy compensatory logic, fuzzy markup language, positional fuzzy logic, propositional fuzzy logic, and so on. Likewise, one of the method fuzzy algebra. Now we see role of fuzzy algebra. To explain the aim and objective of the webinar and also deliver welcome address, I welcome Professor R. Venkatramanan, Head Postgraduate and Research Department of Mathematics, DG Vaishnav College.
Happy and fantastic fuzzy morning. Hope everyone may ready to play your role for this day. I find immense pleasure to welcome our resource person, Dr. K. Arjunan, Assistant Professor, Alakappa Government Arts College, Karaikudi. I welcome with warmth and pleasure the professors, research scholars, students, and every participant on this live stream of 9th webinar of the webinar series 1. I thank earnestly the management, the secretary, Mr. Ashok Kumar Mundraji, the principal, Dr. R. Ganesan, and the faculties of PG and Research Department of Mathematics by fascinating their knowledge and approach for the success of this webinar series. Fuzzy set is a function from x to the closed interval 0, 1, and fuzzy logic is many valued logic with the truth values between 0 and 1. The fuzzy arises only when probability fails. The fuzzy and the probability address only the uncertainty, but in different forms. Fuzzy handles the concept of partial truths. And of course, we are traveling with partial truths in our day-to-day life. Also, no one can escape from these situations on truth basis. Actually, fuzzy logic developed when the conventional computer logic was not capable of manipulating data. A fuzzification of mathematical concepts is based on a generalization of the concepts of straightforwardness, the explosion of possible choices, and the standardization. Fuzzy models or sets or mathematical means of representing the vagueness and imprecise information. The models have the capability of recognizing, representing, manipulating, interpreting, and utilizing data and information that are vague and lack of uncertainty. And also, fuzzy logic is flexible, easy to implement machine learning techniques, photostate the human thoughts. It represents only two solutions suitable for uncertain and approximate reasoning. Also, automotive systems, domestic goods, environmental control, aerospace field for altitude control of spacecraft and satellite are the same. Some of the areas we apply the concepts of fuzzy. The equivalent words of fuzzy are blurred, hazy, blurry, downy, faint, linty, out of focus, pubescent, unclear, unfocused, vague, woolly, smooth, clear, fuzz, blurry, foggy, muzzy, hairy, furry, indistinct, indefinite, shadowy, dim, misty, fleecy, obscure, hirsute, pillows, blur, and cloudy. All these words are related to fuzzy only. Everyone come across the situations of this kind, and we have heard or pronounced at least these words once in a day. In industries, there are so many case studies are available and they may be standard. In this recent situation, that means in this COVID situation, the psychiatrist and psychologist may have the wide opening for research using fuzzy based on the behavioral modification of men, women, children, students in all social sectors. And finally, I conclude by saying miracles are the natural way of the universe. Our only aim, objective, task is to move our fuzzy mind, that is, doubting minds, out of the way. Thank you.
Fuzzy logic is based on observation that people make decision based on the imprecise and non-numerical information. Thank you, sir. Fuzzy models or sets are mathematical means of representing vagueness. These models have the capability of recognizing, representing, manipulating, interpreting, and utilizing data and informations that are vague and lack certainty. To express these more clearly, we have very good resource person with us. I am very happy to invite Dr. R. Arundhati, Associate Professor, Postgraduate and Research Department of Mathematics, DG Vaishnava College, to introduce our resource person.
On behalf of PG and Research Department of Mathematics, DG Vaishnav College, a warm and happy morning to all. It is a great pleasure for me to introduce our resource person, Dr. K. Arjunan, Assistant Professor, Department of Mathematics, Alagappa Government Arts College, Karaikudi, who is going to share his knowledge in fuzzy algebra with us. Dr. K. Arjunan graduated in mathematics in 1977 from Dr. Zakir Hussain College, Ilayangudi, post-graduation in 1999 and MPhil in 2000, both from Alagappa University. In 2003, he did his PGDCA in the same university. In 2009, he completed his PhD in some structures in fuzzy ideal and intuitionistic fuzzy subgroups in Alagappa University. He has nearly 17 years of teaching experience in various reputed institutions. From 2007 to 2011, he worked as the head of the Department of Mathematics, St. Michael College of Engineering and Technology, Kalayarkoil. He has published 97 papers in reputed international journals and 14 papers in national level journals. He has also presented papers in various conferences, seminars, and workshops. He has produced 12 PhD scholars and 38 MPhil scholars. Currently, 4 PhD scholars have submitted their thesis and 6 PhD scholars are doing the research under his guidance. He has delivered 12 invited talks in various colleges. He served as a resource person for various programs, including Service Training Program for School Teachers, National Seminar on Fuzzy Algebra, and one-day workshop on fuzzy logic and its application. He is also a member of Board of Studies in the Rajas College, Pudukkottai. With this brief introduction, I invite you on behalf of PG and Research Department of Mathematics, DG Vaishnav College. Once again, I welcome you, sir. Hand over session to you, sir.
Good morning to everyone. First of all, I thanks to our secretary, TG Vaishnava College, Chennai, and also I express my thanks to our principal of this college and head of the department and staff members of the departments and various department staff members and students and research scholars. I welcome to and also I thanks to you for this attending this type of seminar. So each and everyone, we want to improve our knowledge and our status. So as a mathematician, each and everyone improve the knowledge in our subject. If you have any idea regarding this type of knowledge, each and everyone like this type of. Today I want to share something about the mathematics, particularly fuzzy regarding. So before study about the fuzzy concept, first in your mind, so base is very important in each and everyone. This one is the fuzzy set is extended due to the number. Since in classical set theory, any set can be represented as a characteristic function. In the characteristic function is mapping from x to set interval 0 comma 1. Here in codomain set only 0 comma 1 is there. This is the definition for set theory is a representation of another one format for the set. Here only set intervals are there. So I like to this one, how many numbers lies between this set interval 0 comma 1. In generally in this, you know about the base of the number system, directly answer this type of question. There is no number lies between these two numbers 0 and 1 in the set bracket are there. But some are students are says about that answer for this type of question. Infinite number of elements are there, finite number of elements are there. So this type of answer come from the students. So this is main problem for us. But already we have studied about the number in our previous classes. The number is started in from first standard up to 12th standard. The basic idea is given in clearly regarding number or anything. So number is important in mathematics. One or two places are without the number we can achieve many more results are there. The results are also is related to this number. Each and every results we give the any symbol notation. This symbol the symbol notation is regarding of the number. So each and everyone base is number. So here we know the familiar number system. The corresponding notations are there. Also we know about the number capital N, capital W, capital Z, and capital Q, and capital R, and capital C. Here N equal to, sorry, N is the set of all natural numbers. And then another one symbol we have used the set of all whole number. So two kind of systems are there. First, we generate n as 1, 2, 3, etc. Here, how many numbers lies between 1 and 2? There is no number lies between these two numbers. And similarly, 2 to 3 is also has no numbers lies between these two numbers. And then we add the 0. We give the another one structure. That structure is whole number system. And W equal to 0, 1, 2, 3, etc. The set of all whole number systems. In this, only one number is added from the natural number. We get the whole number system. And similarly, we ask how many numbers lies between 0 and 1. There is no number lies between 0 and 1, and also 1 and 2, and also 2 and 3, and succeeding out of this. And then another one structures are there. Is it? So many different symbols we have used in our subject. Is it equal to I equal to Z, or otherwise any one symbols we can use in any different type of subjects. These are the integers notation for this. Here we add the negative values in whole number system. We get the another one structure formed. That structure is set of all integer numbers. Here is also how many numbers lies between any two succeeding numbers. There is no numbers lies between any two succeeding numbers in this system. In foreign other books, the 0 is also included in this collection. We have used only one symbol notation, capital N. In Indian author, we have used another one different notation. We have used the W symbols. So N is also have the 0. N equal to 0, 1, 2 plus etc. This is also the natural system. In foreign books or in foreign author, we have used only this notation. 0 is also included in these notations. And then another one structures. Q. This is the set of all rational numbers. And another one structure format. Any number can be written in the form of B by Q. That number is called rational number. Suppose any integer number, we can write any number. The power of is also 1. The denominator value is also 1. So we can write as any number has a power 1 and the dividing number is also 1. So this is also the format of P by Q. For example, 3 equal to given, we can write 3 by 1. This is the P by Q form. So this is also the rational number. So any number can be written in the form of P by Q. That number is called rational number. The set of all rational numbers are there in this system. Here, in lower class, the proof of these systems we have proved. Suppose any number is given for the like for this, for example 0.45 0.45 etc. Suppose in our class I asked to the question to the students, this number is rational or irrational. Some students answer to the question for this one, this number is a rational number, sir. Somebody sir says, yes sir, this number is irrational numbers. So this is the one of the difficult for this one, since the base is very clear, directly answer all of them, this number is rational number. Since 0.434343 plus etc is given, we can write as a P by Q form this number. Since we take as a mathematician or anyone, suppose we want to answer for this type of questions, let x is equal to this, we consider the number as a x. So x is equal to 0.434343 plus etc. So this is a one equation. So 434343 is a number is repeated these systems. So we multiple by 100. We get the answer is 100x equal to 43.43 etc. And subtract these two equations, we get the answer is x equal to 0.434343, 100x equal to 43.434343. So subtract these two equations, we get the answer is 42x equal to 43. So this is equal to 43 by 42. So 43 by 42 is a form of P by Q form. So this is number is we replace x. We put the value in 4 by 3 by 42. This is equal to 43 by 42. So we replace x. So the answer for this 43 divided by 42. So this is equal to 0.434343. So clearly this number is rational number. This type of proof is given in 6th standard and 7th standard book. But already we have studied. But today I am studying first BSc Maths and MSc, first MSc Maths, or any MPhil students or research scholar or anyone. You ask this type of questions. So the students are this question is very difficult one. So the base is very important. If you have a strong in basic idea, definitely you will achieve anything in any place, and then you success your life. So the base is important. And then another one structures is in between these two, q and r. This is a irrational number. So irrational number, a number cannot write in the PBQ form. That number is called irrational number. We collect the rational and irrational. We give you another one structure. That structure is real number. The set of all real number systems. We can write the open bracket minus infinity comma plus infinity. This is the representation for the real number. And another one structure is created in this system. And here we can a complex format a plus ib, a comma b belongs to r, the set of all complex number. These are the phase system for this number. As each and everyone, this base is know about this. So automatically similarly in these systems, how many numbers lies between 0 to 1? There is no number lies between 0 to 1. In this system, finite number of there, and the real system has infinite number of elements are there in between 0 to 1. Suppose this is in the definition for the characteristic functions, we in the domain set has set interval 0 comma 1. Here 0 comma 1 element, the 0 comma 1 belongs to real number or anything. We given representation is a set bracket, so only two elements are there. We represent of the 0 1. And then another one very important for this one, set. Set is a collection of well-defined objects. This is another one. A collection of well-defined objects is a theoretical representation for the set theory. So each and every mathematician want to the representation of the symbolic symbolized one. So we want to see a symbolized one. We can create a characteristic function for the any set representation for this one. The characteristic function we know about as a mathematician we must know about the characteristic function. The characteristic function is mapping from psi suffix a of, for the set A, we define the characteristic function psi suffix a is mapping from x to set interval 0 comma 1 by the characteristic of x equal to has a two element, one is 0, another one is 1. If we assign 0 if x does not belongs to a, we assign 1 if x does not belongs to a. This is the definition for the mathematical representation for the set theory. Set is nothing. Set theory was introduced by Cantor in between range of this 1845 to 1980. As particularly 1880s, we find the accurate definition for this set theory. In this, a word is given for this one. Define a set is well-defined collection of the objects. So you know about we know the word for objects and collection and then well-defined. So three words are important in set theory. So everyone know about the objects and also collection. So what is the meaning of well-defined? So this is the new idea for this one, the well-defined. The word is well-defined is word is as a letter in the form of well-defined. We cannot understand about the word for each and everyone in our life. But in generally, this is the meaning of the representation of the well-defined. We give the clear definition for the well-defined. I give you another one. Statements are there. So each and everyone live in world. So we collect the world. We collect the collection from the world, and also we choose the point from the world. These two are in live in world. So I give the another definition. We choose any collection from the world. We choose any point from the world. We can say that the point 100% belongs to the collection. The point 100 plus percent does not belongs to the collection. Your collection is well defined. Your collection is well defined. Okay. So suppose you collect any collection, definitely you collect from the world. So this is the students level. We can easily understand about the world. We well define. We collect the any collection from the world, and also we choose any point from the world. We can say that the 100% element belongs to the collection, or the 100% the element does not belongs to the collection. Your collection is well defined. So again, the students are we can easily understand about the word of the well defined. So set is any collection well defined collection of object. This is called as engine. This is find out in 1880s. And then another one is, this is the base for this. Yeah, each and every one represented as a, suppose you want to study the algebra, suppose you want to study the functional analysis, suppose you want to any type of or there, each and every one represent as a structure form related to the function. Without the function, and also fuzzy is also a function. So the function is very important in our life, and in our life means we use each and every mathematics one, we apply the function related one. Here let a and b be two sets are there, any two sets, and we define the relations f from a to b, a subset of a cross b. This relation is a subset of a cross b, is called a function from a to b if it satisfies the following. A relation is called function if satisfy these two conditions. The given relation is called function. What is the conditions? One is, if for all each and every element in domain, that is the meaning of a belongs to capital A. There is an element b belongs to b such that the order structure belongs to the f. So f is, we can represent it as the ordered pair. Since every function is represented ordered pair, every relation is represented as a ordered pair. So this is the representation of the f. First of all, we say the f is related to the relation. So for all a belongs to small a belongs to capital A, there is an element b belongs to capital B such that a comma b belongs to capital F. Here, the word is very important. For all a belongs to capital A. For all a belongs to capital A. This is very important. For all a belongs to capital A, there is an element b such that a comma b belongs to this. And another one condition, suppose in domain set has more than one elements are there in the codomain, this is not a function. So that condition does not exist in function. So we in the relations, this type of relation are there in the relation. So this one does not exist. Here if a comma b belongs to f and a comma c belongs to f, then b equal to z, b equal to c. So this is the another one condition for a relation is a functions. So generally we can raise the question for these two relation and function. Yeah, every relation is a function, every function is a relation. Suppose asked any interview question, we define or we give the answer, we give the seminar, or we give any interview. We go to any interview. Here you teach relation between relation and function. The question is must raise by the examiner, what is the relation between relation and function. So every function is a relation, but every relation need not be a function. Since some are relations are function, so there we use the word need not be a relation. So this is the function oriented section. I give why should the type of functions are there. In next one we define the fuzzy set. So the base is for function. If you know the function, automatically we understand about the fuzzy set. In previous one, number is given. So since so number is very important for this, due to the number the fuzzy set is created. So this is the main two concepts, and then here we define the fuzzy set. So the many nowadays, most of the universities and most of the college has a fuzzy mathematics is one of the subject in our college. Today some so the basic one is each and everyone know the functions. So the fuzzy set is a function. So function is represented as a x2 closed interval 0 comma 1. Here the characteristic functions changes only one difference here. There we replace the set interval by closed interval 0 comma 1, and 0 comma 1 belongs to this must the belongs to the real number. We can suppose in real analysis we have to study, definitely we say about that 0 comma 1 belongs to r, or in suppose this one 0 comma 1 belongs to the natural number, there is no number lies between these two interval. So very important, 0 comma 1 belongs to the real number. So how many numbers lies between 0 and 1? In that type of interval, 0 comma 1 belongs to r. In the interval has infinite number of elements. So the fuzzy set a on the universal set is a function a from x to close interval 0 comma 1. So the fuzzy set is represented as the ordered pair. Is an ordered pair. First element belongs to the domain set, second element belongs to the closed interval 0 comma 1. 0 comma 1. Here the word is function is given, so that element, each and every element has a unique image. Each and every element has a unique image. Sorry, there exists a image. So this is the definition for the fuzzy set. And another one is the fuzzy relation. The word is the strongest fuzzy relations. Since here the fuzzy relation and also the strongest fuzzy relation is given, this is the strongest fuzzy relation is used for the fuzzy graph. Since we generalize one for the fuzzy graph, so the strongest fuzzy relation is needful to help of the of a set, the strong on S, there is a fuzzy relation V with respect to A given by this one. So here a set is a set is a set is a fuzzy set A is also defined the set S. A fuzzy set is also defined the set S. With the help of the fuzzy set A, we find the fuzzy relation. We find the fuzzy relation using the fuzzy set A. So set is given, and also we define the fuzzy set, and then the help of A we find the fuzzy relation. The relation is given there. V of x comma y equal to minimum of a of x comma a of y for all x and y belongs to x. So this is the meaning of that one. This definition useful to fuzzy graph related work in fuzzy graph theory. And also this one is used in fuzzy algebra. Suppose you want to the proof of any algebraic structures are given. Suppose A is a fuzzy subgroup, show that the strongest fuzzy relation is fuzzy subgroup or not. So using the definition, we can find that this fuzzy, the given fuzzy set is also a fuzzy, strongest fuzzy relation is also a fuzzy subgroup. So this definition is very useful to us. And then binary operations. So here the binary operation is very important in algebra. So in the binary operations, very important. Suppose what is the meaning of binary operations? So the binary operation is also a function. Binary operation is also a function. So each and every place we use the functions in algebraic structure or analysis structure or anything, without the help of functions we cannot move anything. If a set is important, and related to the function is also important there in these collections. Okay, let S be the non-empty set. A binary operation star on S is a function. The star is mapping from S cross S to S. This is the functions. That function is called relation. So a function is called a function. Which type of function is called fuzzy set? Which function is called binary operations? A function is called fuzzy set. Any sets domain is a set. Codomain must close interval 0, 1. This type of function is called fuzzy function. And another one is a function is mapping from S cross S to S. This type of function is called operations. This type of function is called operation. Here, the one examples are there in this related to this one is plus a binary operation in this set. The binary operation exists in the set is does not exist in the. Clearly, this function is does not exist since. So suppose we use these structures, we define the map of this to one. This is the map. Here the plus is a binary operation means a star. We replace the star by plus. We put these collections. We form the structures. We draw the diagram in codomain collection as 1, 1, 1, 2, 1, 3, and similarly 2, 1, 2, 2, 2, 3, and also 3, 1, 3, 2, 3, 3, and tends to s is equal to 1, 2, 3. So we can form a function of this type of one. We cannot form these functions with respect to the usual addition. The plus is a notation for the usual addition. So use the usual addition. This is the operation for the usual addition. We cannot we add this to number, we get the result is does not exist in the S. For example, 2 plus 3 equal to 5. 5 does not belongs to S. So this plus is does not exist in the binary operation in that set. But generally plus is a binary operation in what sets? If binary operation exists, we proceed the next one for this group or ring or anything. So first is very important. Binary operation is very important in this. So another name of the binary operation is nothing but the closed. The binary operation is nothing but closed. Closed equal to binary operation. Both are same. So one or two book. Suppose the star be operation and another books are written as star be a binary operation. If you give the binary operation directly, we give the following conditions are there: associative, identity, inverse. Or otherwise, suppose the star the operations, we must say about the star is closed. This is the condition is very important if give the star is operations. So this is the main difference, these two definitions. So this is the binary operation for this one. So is the plus a binary operation on S or exists or not? It's not. Thus plus is not binary operation in the set S is equal to 1, 2, 3. And the next one is group. So all of you know about the group theory, and student third year students level and above MSc or research or above the degree, all of know about the degree means particularly the mathematics. If you have if you know the about the group theory definition. So here a non-empty set G together with the binary operation star is called the group if the following conditions are satisfied. First one is star is associative and identity exists and inverse exists for all elements. So here, yes, here we give a name for the set. So one or two place a function take another one name. Similarly, and also a set is take another name with respect to the new structures. So here G be a set, the set is called group. If satisfy the following condition, the inside of the element, we apply the operation to inside the element, we get the answer is the set is called group. The set is called group. Here the structure G comma star, the G comma star. After that, in book or anything, suppose we have to study the G be a group, G be a group. So default the star is included in this collection in the structures. So G comma star or anything with respect to the by any one binary operations, the clearly the given structure is a group. Given structure is a group. So non-empty set is called group if the non-empty set has the following three or four. This is the first one is binary operation, and with respect to the operation, by the second one is associative, and then identity, and also inverse exists for all element. This is the another one structures. Another one structure. The structure is called a group. So each and everyone know the associative conditions and identity. The unique identity is in identity exists. That's all. Each we know the theoretical proof and the theorems who has a group has only one identity. So the identity exists. That identity is unique. That identity is unique. And also the inverse exists for all elements. This is the very important for all elements. So each and every element has a inverse element. Suppose any two elements are exist inverse, so third element does not has a inverse. This collection is not a group collections. A given collection is not a group collection. So this is the very important for all element has a inverse exist of all element. The given collection is called a group with respect to the operation. And the next one, this is a simple example for regarding the group theory. -1 0 comma 1 the plus a group. Suppose we without using the Kelly table or closed operations for more than one element has there. Suppose we use the condition -1 plus 0 equal to -1, 0 plus 1 equal to 1, and -1 plus 1 equal to 0. So and identity 0 is the additive identity. The inverse of 1 is -1. Inverse of -1 is 1. So clearly this is group. So approximately this group for this structure. But in depth, you use the we use the what is the meaning of closed? What is the meaning of closed? The closed is a binary. So binary exists or in this sets for the plus. So binary is does not exist in this collection. So this is not a group. So binary means, so any two, if you take any different, we not take any two different element. We take any element. That element maybe both are same or both are different. So suppose I want to take the 1 comma 1. This is the two elements. This is not a two different element. So two element. Suppose I take 1 comma 1. So 1 plus 1 equal to 2. 2 does not belongs to the collection. So the binary does not exist in this collection. So we cannot say that the given voice is not a group. So clearly this is not a group due to the binary does not exist in this collection with respect to the ordinary usual addition and ordinary usual addition. And the next one is fuzzy group. So fuzzy group, fuzzy subgroups. What is the difference between these two? Are so generally we have the clear given that G comma plus be a group. And what's the definition of fuzzy group? So the word is fuzzy subgroups are there. What is the difference between fuzzy group and fuzzy subgroup? Okay, so fuzzy group and fuzzy subgroups is slightly different between these two terms. Here, the G plus be a group. If you form the given group with respect to the characteristic function, clearly is also a fuzzy group. So the group is called the fuzzy group. So we create any structures of these conditions that condition. If you satisfy this type of condition, your structure means the fuzzy set is called fuzzy subgroup. So I give the clear definition for this one. G comma plus be a group, a fuzzy subset A. First name is a fuzzy subset. A fuzzy subset A of G is said to be fuzzy subgroup of G if the following conditions are satisfied: A of x plus y and greater than or equal to minimum of A of x comma A of y, and A of minus x greater than or equal to A of x for all x comma y belongs to G. So here G comma plus, here we use the plus is a operation, and I take the plus is ordinary addition. Suppose I take the ordinary addition. So the given structure C with respect to the ordinary addition, the given structure is a group. And another one word is a fuzzy subset of A of G. What is the meaning of a fuzzy subset of A? A fuzzy subset A of G. What is the meaning of A? This is the function from G to closed interval 0, 1. A fuzzy subset A of G is nothing but is a mapping from A is mapping from A. The mapping A is mapping from G to closed interval 0, A mapping A is from G to closed interval 0, y. This fuzzy set is called fuzzy subgroup if satisfy these two conditions. The given fuzzy subset of G is called fuzzy subgroup of G. Okay. So what are the conditions are there? A of x plus y greater than or equal to minimum of A of x comma A of y, and a of minus x greater than or equal to a of x, comma, for all x comma y belongs to 6. Okay, here we give the greater than symbol. Here this is also a greater than symbol. Here give the minimum of. Why we use minimum? Suppose I want to use maximize. Suppose I want to use equal. Suppose I want to use less than. Why should you apply this here greater than or equal to minimum? So suppose as per the definition of the group theory, if you take any element, the resultant element belongs to the collection. This is the first one. If you take any element from the set, with the help of the operation, the resultant element is also belongs to this one. Suppose the resultant element belongs to, suppose you take any two element, both are suppose one is this is the fuzziness. With respect to the fuzziness, we assign the membership value for this one. Suppose any two values, that element belongs, one is belongs to, another one is does not belongs to the collection. Suppose we give the one, the element belongs to the one, that is the meaning of one. That element does not belongs to the collection. There is the value, the membership value of this one equal to 0, and we apply the maximum value. This is equal to 1. The resultant value maybe does not belongs to the collection. What is the answer? This condition is does not exist. Suppose we use maximum greater than. So this is the main problem regarding of this one. So we fix the minimum of a of x comma a of y, minimum of a of x comma a of y. After that we use the minimum of, the minimum is regarding for the closed properties, and also second one, second closed property, and also associative is also used the close mingle of the closed, but only one condition is both are equal, both are equal. So this is also a closed conditions are there in this associative. After that, identity is also is as per the closed concepts. Since E star A, this is closed, the resultant value, and also A star E, this is also a one you give the one element, this is also a resultant value. The resultant value belongs to E. So each and every structures of in group theory, if you take any two element, we apply the given operation, the resultant value belongs to the collections. This is the main concept of this one. So we use a of x plus y, a of x plus y. Here the plus means this operation. Suppose we replace star, this is also changes star. So with respect to the operation, we have find the values if x and y belongs to G, x comma y belongs to G. So a of x is nothing but the closed interval 0 comma 1. The a of x comma y belongs to closed interval 0 comma 1. Since a is a fuzzy subset of from G to closed interval 0 comma 1, we apply the fuzzy, these two are this is the resultant value belongs to G. So the image of the element belongs to closed interval 0 comma 1. So a of x comma y belongs to closed 0 comma 1. And also minimum of, we find the separate image of x and y, and again find the minimum of these two, the minimum result greater than or equal to, and then using the operations of the resultant value of the image is greater than these two elements. Okay, so this is the first condition, and second condition, a of minus x cannot equal to a of x for all x comma y belongs to this. This is the inverse concept. This is the inverse. Suppose we take any element from the set, the last one says that the inverse is also belongs to the collection. Inverse exists, that the exist element is also belongs to the collection. So if you take any element, so inverse element is also belongs. So suppose in group theory, A and B are any two element, A is a inverse of B and also B is a inverse of A. This is trivial true. So after that, the definition is converted into the equal one. After the first introduce the other the Rosenfeld, the fuzzy subgroups first define the Rosenfeld, give the definition a of x comma x plus y cannot equal to minimum of a of x comma a of y, and then a of minus x cannot equal to a of x for all x comma y belongs to G. And after that, we use the properties. If suppose A and B are any two element from the group G, so A is a inverse of B and B is a inverse of A. So we use this first one to second one to first one. We can replace as A of minus x greater than or equal to A of x, and also A of x greater than or equal to A of minus x, using these two results. So we get the simplification as A of x equal to A of minus x. So the definition of nowadays, this definition converted as a of minus x equal to a of x. A of minus x equal to A of x, and then one or two other we use to mingle these two conditions. We give the single one A of x minus y greater than or equal to minimum of A of x comma A of y. A of this is a mingle of these two conditions, we get the single one A of x minus y greater than or equal to minimum of A of x comma f. Suppose the given was in the given operation is a star, or otherwise given the operation is multiple, we use the symbol, we use one x y inverse, x into y inverse. So this is the meaning of inverse of x. The minus means inverse of x. This is not a subtraction, this is the inverse of the element. Minus x is the inverse of x, inverse of x. This is the mind in your mind. So the here G be a group, a fuzzy subset A of G is said to be a fuzzy subgroup of G if the following conditions are satisfied. These two conditions. After that, these two are mingled as a single one. We can write as A of x minus y greater than or equal to minimum of A of x comma A of y, or otherwise A of x plus y greater than or equal to minimum of A of x comma A of y, and then A of minus x equal to A of x. So we use different type of definitions are there for the fuzzy subgroups. And the next one is example for the fuzzy subgroups. Here I give the one example for the fuzzy subgroup. We use the in four groups. We have some elements are there, E comma A comma B comma AB. The relations between the A E A B A B is given as A squared equal to B squared equal to E, and also AB equal to BA. This is the relations between E A B A B. So we define the fuzzy set A equal to we define the fuzzy set for the set G. We get the values E comma with respect to the function. This is the function. A is a function. With respect to the function, we give the value 0.8, and also A has a 0.6, and B has 0.4, and AB has 0.4. Okay, so this is the membership value for each and every element for E. Okay, this may be 0 since the element belongs to closed interval 0 comma 1, so this elements lies between 0 to 1. With respect to the function, we are seeing the membership values. Okay, with respect to the function, we give the membership value 0.8 and 0.6 and 0.4, and then also 0.4. This is the fuzzy set. I want to verify this fuzzy set is a fuzzy subgroup or not. Okay, what I do, suppose we use the procedure previous we go to the previous step. Suppose x plus y, here x plus y or mingle of these two, we can give the single condition A of x minus y greater than or equal to minimum of A of x comma A of y, A of x minus y. We apply this one. Suppose x is equal to A, y equal to b, and then x is equal to a, y equal to b. What is the first condition one? A of x minus y, A of x minus y. I want to find A of x minus y. Okay, find the A of x minus y. X is equal to a, y equal to b, and A of x minus y. First find the x minus y. Here x minus y is nothing but x, and in operation, and also with inverse of b, inverse of b. Here we use the same conditions of there, a inverse of b, inverse of b, inverse of b is also b, since b squared equal to e, so b the b each and everyone has a own inverse, each and everyone has a own inverse. So the inverse of a equal to a, inverse of b is also b, a inverse of ab is also ab. So this is equal to b is given, so inverse of b is also b, so again b, so we get the answer is ab, we get the answer is ab. So here the operation is multiple operation. With respect to the multiple operation, the given structure is group, the given structure is group. So a dot b, a dot b is nothing but ab, a dot b is nothing but, here is also dot, this is also a dot, nothing but ab. So the membership value of ab, what is the value membership value of ab? Ab equal to 0.4. So a of A dot B inverse equal to A of capital A of AB equal to 0.4. So the left side value for the condition 0.4, and also find the right side values. We take two elements. These are A and B. So separate membership value, separate image of A and B. What's the image? Separate image. That is the meaning for membership value. The membership value of A is 0.6, and also membership value of B is 0.4. We find the minimum of these two, so 0.4. So already we have found 0.4. Okay, so find the minimum of these two, the 0.4. So the 0.4 equal to 0.4. Similarly, we can check and each and every one for this. So here the totally 16 possible cases are there. We using the Cayley table. 16 possibles are there. With respect to the 16 possible, all possible cases are satisfy the fuzzy subgroup condition. So the given fuzzy set A is called fuzzy subgroup of G. Okay, so each and everyone we check and verify the condition for this. So the given fuzzy subgroup of A is another one definition for the fuzzy normal subgroup. Let G comma dot be a group. A fuzzy subgroup A of G is said to be a fuzzy normal subgroup if A of xy equal to A of yx for all x and y belongs to G. So first we verify the given G be a group. First we define the fuzzy set. First after that we verify the given fuzzy set is fuzzy subgroup or not. Suppose the given fuzzy set is a fuzzy subgroup. After that we verify these conditions. If the condition is satisfied, the given fuzzy subgroup, the given fuzzy set, the given fuzzy subgroup is also called fuzzy normal subgroup of G. So this is the another one definition for the given fuzzy subgroup. And then these are the some example some properties and also some theorems. I give the result. I give the name as a result. This is treated as a one result on one property and one theorem. For our convenience we take the result. If A is a fuzzy subgroup of a group G, then A of x inverse, already I have told I have already told you A of x inverse equal to A of x, both are equal, and also A of x less than or equal to A of e. This is identity elements are greater than. Identity elements are greater than for every element. Suppose 0 is the identity element. In the previous problem, we can see E equal to 0.8. Here A equal to 0.6, B equal to 0.4, 0.4. So E is the identity element. So identity element is greater than compared to other one. The membership value of this one equal to 0.8. The remaining is 0.6, 0.4, and 0.4. So this is the condition for this one. So with respect to the given fuzzy subgroup, the theorem we can form. So, then A of x inverse equal to A of x. And also A of x less than or equal to A of e. The identity element of the membership value is greater than compared to the other one, for all or other. All or other. These two results are there. If A is a fuzzy subgroup of group G, so automatically these two are true. And also another one symbol results are given. One is if A is a fuzzy subgroup, then A x y inverse is equal to A of E gives A of x equal to A of y for all x comma E belongs to G. This is also another one theorem and also another one property for this fuzzy subgroup. If A is a fuzzy subgroup of a group G, suppose this is another A is a fuzzy subgroup of a group G, then A of x y inverse is equal to A of E gives A of x is equal to A of y for all x comma E belongs to G. Here E is the identity element for the group G. So the membership value of the identity element equal to If you the membership value of x, y inverse both are equal, clearly a of x equal to a of y. A of x is equal to a of y. A of x is equal to a of y is nothing but the membership value of x and the membership value of y both are equal. Both are equal. So if the membership value of identity element equal to the membership value of x, y inverse, then clearly the membership value of x equal to the membership value of y. So this is the result for the fuzzy. If A is a fuzzy subgroup, we get the result a of x inverse is equal to a of e equals a of x is equal to a of y for all x. And the next one is this is the least upper bound and greatest lower bound. These two are necessary for our fuzzy concept. Since if you use the we have used the function related function related fuzzy concept we have used. This is the must for least upper bound greatest lower. This is the nothing but LUP and CLP, supremum and infimum. We want to supremum and infimum. So this is the necessary for this one. So least upper bound. Okay. We have each and everyone we have studied in basic level in mathematics and particularly the relations oriented concepts. We have studied b comma r is nothing but the relation, be a Boset. Boset is nothing but partially ordered set. You know about the partially ordered set. A relation is called a partially ordered set. The relation has three axioms. First one is reflexive, second one is antisymmetric, and the third one is transitive. So the three conditions are satisfied. The given relation is called partially ordered relation. A set has at least one partially ordered relation. The given set is called partially ordered set. So it's not the partially ordered set is not is short as read as poset. Broadest poset. So this is the poset definition for this one, and also that A be the non-empty subset of P, and another one structure let A is subset of the given poset. Given poset. An element U belongs to B is called an upper bound. First to find the upper bound. From the upper bound, we find out the least upper bound. So this is the first one is upper bound. If I want to say about the U is an upper bound, if satisfy the conditions, A relation U A relation U for all A belongs to E. For A relation U, this condition is satisfying for all A belongs to A. The given U is called the upper bound. So first to collect the all upper bound from this set. After that, from the upper bound, I find out the least upper bound. I find out the least upper bound. This is the meaning of that one. An element U belongs to B is called the least upper bound of A. First one, U is an upper bound of the A. And also, if V is an any other upper bound of A, then U relation V. U relation V. So this is the least one. So more than upper bound are there. Suppose we find the least one for this upper bound. We find the least one for this upper bound. Okay. So this is a definition for this one. This is called the this element is that u is the supremum of our collection. Supremum of our collection. We use the basic level in the corresponding for the supremum. Supremum is nothing but maximum, and also infimum is nothing but minimum. But these two properties are entirely different. This one is used only for the given structure is infinite. Suppose okay, if you use supremum, we cannot apply one or two place. We cannot apply the maximum values, and one or two place we definitely use infimum. We cannot use minimum. But if you use supremum in any place of this one, okay. So this is one, and element U belongs to B is called the least upper bound of A. If U is an upper bound of A, if V is any other upper bound of A, then U relation V. This is the supremum for this. We find out the supremum element for the given collections, and also greatest lower bound. Similarly, same results are applied, and B comma R comma B posets. Let A be a non-empty set of B, and element U belongs to B is called lower bound. First, to find the lower bound of the collections. We find the collection of we find the lower bound from the collection. From the lower bound, we find the greatest lower bound. That is called infimum. That is called infimum. So this is the definition for this one. An element U belongs to B. An element U belongs to B. B is called the greatest lower bound of A if U is a lower bound of A and V is any other lower bound of A, then B relation U. B relation U. This is the definition for the infimum. This is the definition for the infimum. Oh, so the above definition is help to us we find the function oriented function oriented problems and function oriented theories. This is another one definition for the fuzzy concepts. Suppose x and x dash be any two sets. I give the ordinary function from x to x dash and let a be a fuzzy set in x. Okay, let a be a fuzzy set in x. Here two structures are there. Let x and x dash any two sets. F is a function from x to x dash be a function. These two are already we have seen in previous one. Here a fuzzy set in x. I define the fuzzy set in x. With the help of the fuzzy set and with the help of the function, we find the fuzzy set v in f of x. We find in x in f of x. We find the fuzzy set in this is f of x is nothing but x dash. This is a x dash. So this is not f of x. This is a x dash. Okay, so x and x dash be any two sets. F is mapping from x to x dash be any function. Let a be a fuzzy set in x. So x and x dash is given, function is given, a be a fuzzy set is given. With the help of the with the help of the relation, we find the fuzzy set v. We find the fuzzy set v. Okay, okay. The v is a fuzzy set in codomain. Okay, so if you give a fuzzy set in domain set, with the help of the function, we can find the fuzzy set in codomain. So this is the relation between these two. So what is the definition for this one? Suppose I want to the membership value for the codomain element. With the help of the relations, we can find that v of y equal to supremum of a of x. Here the supremum of a of x is given. For this previous, I have give the supremum concept. So supremum of a of x. Since the membership values closed interval 0, 1 is given, suppose any finite collections are there, we can use minimum or maximum. We can use the minimum or minimum. We can use a minimum operator or maximum operator. With the help of the minimum operator or maximum operator, we can find the value for this one. We replace this supremum by maximum. We find the value of that one. Suppose the given fuzzy set is a function. That function is the image of the function. The image of the membership. The membership value of the element has a infinite one. We cannot find the use of maximum or minimum. Since minimum is an operator, maximum is also an operator. This operator is first define the operator for two element. After that, the operator is extended into the finite collections. So minimum, maximum we use. If you use, we can use minimum, maximum only for finite collections. If you infinite collections are there, we cannot use the minimum maximum operators. So suppose the closed interval 0, 1 is an infinite number of elements. Suppose infinite number of membership values are there, definitely we use the supremum or infimum. Already the closed interval 0, 1 is a poset with respect to the relation of less than or equal to. So already I have told in this definition for the greatest lower bound and the least upper bound. In this definition, first words is p comma r be the poset. If you define the poset for if the given set is poset, after that we can find out the supremum or infimum. Okay, so the closed interval 0 comma 1 is a poset or not is clearly poset. Since suppose I have used the relation less than or equal to with respect to the relation clearly reflexive, antisymmetric, transitive. So the given closed interval 0 comma 1 is a poset. So the given closed interval 0 comma 1 poset with respect to the relation also. So we can find the greatest lower bound, least upper bound. So greatest lower bound is nothing but supremum, least upper is nothing but minimum. So we can use this v of y equal to supremum of a of x. So here f of x is equal to y. This is the meaning of the relation between x and y for all x and g. And then if function does not exist, suppose the codomain set is suppose the given function, the given Fuzzy function, this is not a 1 1, need not be a 1 1, need not be on 2, need not be a bijective. So this is the function. Suppose the function is 1 1, f of x is equal to y, we get the all values from this one. Suppose the given function is not 1 1 or not bijective. So remaining value, how to find the remaining value for the membership values? So remaining membership value all are treated as 0. Okay, so the another next one, I give the another one example for this related one. So this is the meaning of that one. So 0 elsewhere. And also A is a called preimage of B under F and is denoted by F inverse of B, comma 0 elsewhere. Okay, here the example, clearly the given example is given for regarding of previous definition. X is equal to a comma b comma c, and x dash is equal to 1 comma 2 comma 3 comma 4. And also this is the f is nothing but the fuzzy, f is nothing but the given f is fuzzy set. Sorry, the given f is a function. Function is the image of a is 1, the image of b equal to 3, the image of c equal to 1, and image of d equal to 2. This is the function. And so v equal to, so this is here v equal to first one in the previous definition. So first find the membership value of each and every element in codomain values with the help of a. Suppose the free image of a, how many numbers are there? The free image has two elements. One is a and c. A and c are free image of the element 1. So here two elements are there. So the corresponding membership value also there. A equal to 0.3, c is equal to 0.5. From the definition, supremum of these two element. Supremum of these two element, a comma 0.3 and c comma 0.5. Find the maximum value of this one. Find the maximum value. So this is equal to maximum value equal to 0.5. So we put the membership value for the element 1 as 0 is 0.5. 0.5. After that 2. So 2, the free image of 2. So only one element t. So we take the membership value. 2 has a membership value same as the membership value of d. So since the t has only one free image, so we take the value for that one. So the membership value of 2 equal to the membership value of t. So this is equal to 0.4. Sorry, d values 0.6. So 2, the membership value of 0.2 equal to 0.6. And also 3. So 3 has a free image, only one free image, 3 b. So the membership value of b is equal to membership value of 3. So this is equal to b has a membership value 0.4. So 3 is also has a membership value 0.4. And the next one, 4. 4 has no pre-image. We have seen the membership values. Already the word is given for the previous one, 0 elsewhere. 0 elsewhere. So the 4 has a free image. The 4 has not free image. So the membership value of 4 is 0. So this is the definition for the previous one. Okay. And then also in the previous one, next one is up to this one, if A is a fuzzy set in codomain, with the help of the fuzzy set, we find the fuzzy set B in codomain, for codomain. Similarly, V is a fuzzy set in codomain. With the help of this definition, we find the fuzzy set in X with the help of V. With the help of V. This is the another one. This is the meaning of that one. A is called pre-image of B under F and is denoted by F inverse of B, comma 0 elsewhere. 0 elsewhere. Suppose here this is equal to. Again using these functions, this is the given. X is given, X dash is given, F is given, V is given. In previous one, X given, X dash given, F given, A given, we find V. In this one, X given, X dash given, F given, V given, we find F inverse of V. F inverse of V is nothing but A. F inverse of V is nothing but A, capital A. So V equal to 1 comma 0.4, 2 comma 0.8, 3 comma 0.5, and 4 comma 0.3. 4 comma 0.3. Then F inverse of V. With the help of our definition, we find the F inverse of V. We find the F inverse of V here. In domain set has 4 element A, B, C, D. Suppose I want to fix the membership value for A with the help of the function A. The image of A is 1. So already we give the membership value 0.4. So we fix the membership value for the element A is 0.4. So the membership value of A equal to membership value of 1, both are equal. And also the membership value of B and membership value of 3 both are equal, and membership value of C and membership value of 1 both are equal, and membership value of D and membership value of 2 both are equal. So this is the way of to find the membership value for the corresponding F inverse of B. So A equal to 1, so A 0.4, B 3, so B 3 has 0.5, B equal to 0.5, C 1, C 1 equal to 0.4, D 2, D 2 equal to 0.8, but T equal to 0.4. Using this is the example for the previous one. And the next one algebraic structure is ring. So many more algebraic structures are there. In the last section, I tell you for how many algebraic structures are there, how many fuzzy sets are there. With the help of the fuzzy set and algebraic structure, we can develop the many more results from this. Use the help of the fuzzy structures. Here are be the ring, and similarly same structure. This is the ring. Ring has a two operation. With respect to the first operation, the given structure is abelian group. Second operation is closed associative, and after that the distributive law is satisfied. The given conditions, the given R, the set R is with respect to the two binary operation is called a ring. Okay, and then the fuzzy subset of the fuzzy subset A of R is called a fuzzy subring of R. In the following conditions are satisfied: A of x minus y greater than or equal to minimum of a of x comma a of y. A of xy greater than or equal to minimum of a of x comma a of y for all x comma y belongs to R. So this is the definition for this. This is the necessary and sufficient condition for the ring. So we, with the help of the necessary and sufficient condition, we form the this one. So already I told you in previous group structure, we can mingle of these two. We get a single one as a of x minus y. A of x minus y. Thus, x minus y is a sufficient condition for the group structure, and also this is a ring structure. So these two are the sufficient conditions. Suppose the sufficient conditions for enough for this algebraic this for the fuzzy structures. So this is the another one condition is the same structure. We can use the same one. A of x minus y is not equal to minimum of a of x comma a of y, and a of xy minimum of a of x comma a of y for all x comma y belongs to R. And consider the this is the example for this one. The generalized function is given for this one. If x is a even structure, we assign the membership value 1. Otherwise, the 0.5 5. With the help of these functions, clearly a is a fuzzy subring of z suffix p. The p is a prime number. The p is a prime number. This is the example for this one. And next one is this is the only definition for the graph theory. In generalized one for graph, already the graph theory is developed in many authors and many way. This is my structure for the fuzzy graph. Already each and every graph is a single graph, but multiple structures are used, but the definition only used for this simple graph. So that definition is need not be used multiple structure. So here this definition is used all and each and every graph theory structures. Multiple structure or simple graph or multiple graph or anything given, we can generalize this definition. The strongest fuzzy relation is helpful too for this type of fuzzy graph developing this. Let V be the non-empty set and E be any set. F is mapping from E to V cross V, be any function. Then A is a fuzzy subset of V, S is the fuzzy relation on V, then B is a fuzzy subset of E such that B of E is not equal to S of x comma y, where E is a pre-image of x comma y, then the order triple F comma then the order triple F A comma B comma F is called the fuzzy graph. So here the given this is the fuzzy graph is the generalized one as a graph theory. For each and every graph structure, we can develop as use of this definition. This definition is the generalized one for the graph theory. Let V be any non-empty set. Let E be any set. F is mapping from E to V cross V, be any function. This is the function for this one. And then A given with respect to the edge set, with respect to the set V. So here E is a edge set, V is a vertices set. We define the relation between these two. F is mapping from E to V cross V. And then we form the fuzzy structure from this. Then A is a fuzzy subset of V, and also S is a fuzzy relation on V. With the help of A, we can find the fuzzy relation V, and also B is a fuzzy subset of E. Then B is another one fuzzy set. That fuzzy set is defined from E, but the relation is given. The edge of the membership value should be less than or equal to. So this is the meaning of that one. Is with the membership value should be less than or equal to S of x comma y. S of x comma y is nothing but minimum of a of x comma a of y. So that value b of e should be less than minimum of a of x comma a of y, where here e is the pre-image of x comma y. Since f is a function from e to v cross v x comma y, suppose we can form the more than one edge from the graph. So we find the fuzzy structures for the multiple edges or loop or there anything. With respect to the loop, with respect to the multiple, we can define the degrees and everything or graph structures, or we can develop regarding of this one. Then the order triple, then the order triple f a first must a fuzzy subset is must, and after that b is also fuzzy set, f is relations. These are the necessary for this one. So this structure is called fuzzy graph for these ones. And another one definition. So different way of in fuzzy structures are there. So first one is algebraic structure, another one graph theory structure, and after that fuzzy topology, and many more structures are developed in fuzzy. I give only for three structures are there. Only another one is fuzzy topology. And let S be the set, and then script I be a family of fuzzy subsets of S, and the family of this is called fuzzy topology on S, and the script I satisfy the following axioms. The 0s and 1s belongs to this one. The 0 is nothing but each and every membership values 0. 1s is nothing but each and every membership value is 1. So this is a nothing but empty set. This is the whole set. This is nothing but empty set, whole set. As per the function, we define the notation 0s, 1s. This is the empty set. This is equal to a whole set. After that, the collection of fuzzy sets are there. From the collection, arbitrary unions or finite intersections are satisfying. In a topological space, already in a topology, we have three conditions are there: empty and x belongs to tau. Arbitrary unions are belongs to tau, and finite intersection belongs to tau. So this collection, the given subset is called topology. That if a set has at least one topology, the given structure is called fuzzy topological space. Similarly, we can use this fuzzy topology. Let us be the set. This is the collection, and that collection has a topology. Then satisfy the topology. After that, we form the topological space. This one is called S comma script I is called the fuzzy topological space. So 0s is nothing but empty. 1s is nothing but whole set. Arbitrary union exists, finite intersection exists, then that collection tau is called fuzzy topology. If the set has at least one fuzzy topology, the given set is called fuzzy topological space, and then the members of tau are called fuzzy open. The complement of the elements are fuzzy closed, and so on, and everything is up to the based on the topology. The topology is extended into the fuzzy topology structures with the help of the fuzziness. And then here these are this is useful to the research scholar and teachers and guiding different type of fuzzy algebraic structures we can use. These are the different type of fuzzy are there in this. Suppose you write if you write any thesis, this thesis we can easily converted or easily develop in another one structures with the help of this one. So generally fuzzies are many more types of fuzzy. I give the one or two. This one, first one is anti-fuzzy, and another one is T fuzzy, and another one is L fuzzy, and then Q fuzzy, or interval valued fuzzy, multi-fuzzy, indeterminate fuzzy. So the anti-fuzzy is nothing but only for the given change of relations. Suppose we replace greater than or equal, we replace the greater than by less than, and then minimum by maximum. This algebraic structure is called anti-fuzzy. And T-fuzzy, here we replace minimum by the T norm. We replace the minimum since you know the T norm definition. So T norm is minimum operator is one of the T norm. So we generalize the minimum concept as a T, with the help of the T norm. With the help of, so replace minimum by T. So T is nothing but T norm. It's nothing but T norm. And then next one is L fuzzy. L fuzzy is nothing but we replace the codomain structures. Since closed interval 0, 1 is a lattice, closed interval 0, 1 is a lattice. So this is a particular lattice. So suppose I want to generalize the lattice, so we replace the closed interval 0 comma 1 by L. So this type of fuzzy is called L fuzzy. So the Cartesian product of algebra and set, we use the same conditions. This structure is replies is nothing but G by G cross Q. G by G cross Q. This structure is called Q fuzzy. And the next one is interval valued fuzzy. This is also the we replace the codomain structures. The codomain structure is closed interval 0 comma 1. Suppose I want to replace the closed interval 0 comma 1 by d of closed interval 0 comma 1. So the d of closed interval 0 comma 1 is nothing but the collection of sub interval of closed interval 0 comma 1. This type of fuzzy is called interval valued fuzzy. And the next one is multi fuzzy. Multi-fuzzy means multi functions. Multi functions are there, that multi structures are created. So only ordered pair is given in fuzzy set. I want to extend this structure into finite structure. Suppose a1, a2, a3, these are the different fuzzy structure with respect to the this one. We can define the x comma a1 of x comma a2 of x comma a3 of x, etc. A comma an of x. This structure is called multi fuzzy. And then indigenistic fuzzy. And indigenistic fuzzy, this is the another one structure. This is the generalized form of the fuzzy set. This is the each and every one is also the generalized one. This is the indigenistic fuzzy. Indigenistic fuzzy is nothing but first one is membership value and another one is non-membership value. The ordered triple structure. You can x membership value and the non-membership value, only one conditions are there. The sum of the membership value and non-membership value should be less than or equal to 1. This is the main condition for this one. So this is called this type of structure is called indigenistic indigenistic fuzzy. Okay, and after that next one is bipolar valued fuzzy. This is a bipolar valued fuzzy, and bipolar is nothing but the closed interval 0 to 1 is extended -1 to +1, and then after that these two are separated as -1 to 0 and 0 to 1. This type, the structures of the bipolar valued fuzzy set x comma the positive membership value and then negative membership value. This structure is called bipolar valued fuzzy set. And the next one is negative fuzzy set. Negative is nothing but we replace the closed interval 0 comma 1 by closed -1 comma 0. And then vague structure is created. The closed interval of the complement of the fuzzy to complement, this is equal to vague set. And also soft set. Soft set is a soft structure. That soft structure converted into the fuzzy concept, we get the soft structures. And next one is these are the anti-fuzzy subdivisions. Anti-fuzzy is divided into some subdivisions of that. Anti-Q fuzzy, anti-L fuzzy, anti-S fuzzy, anti-interval value fuzzy, anti-multi fuzzy, anti-multi interval value fuzzy, and then anti-multi LQ fuzzy, anti-multi Q fuzzy, anti-multi S fuzzy, and this is the S means T conum. This is a notation for the T conum. This is a T is a notation for the T norm. T conum is a notation as capital S. Anti-indigenistic fuzzy and anti-indigenistic L fuzzy. And then this is the type of multi-fuzzy structures. Multi-Q fuzzy, multi-L fuzzy, multi-S fuzzy, multi-interval fuzzy, multi-indigenistic fuzzy, multi-indigenistic interval fuzzy, and then next ones. Multi-negative fuzzy, multi-negative Q fuzzy, multi-negative interval fuzzy, multi-interval value Q fuzzy, multi-indigenistic L fuzzy, multi-indigenistic interval value Q fuzzy, and then another one structures. The indigenous fuzzy set has these are the different one. Indigenous L fuzzy, indigenous Q fuzzy, indigenous TS fuzzy. TS is nothing but T norm, co norm. we replace the minimum and also maximum. For minimum T, for maximum S, and then LTS and QL and QTS and L, and then this is the indigenousic interval valued L fuzzy, indigenousic interval Q fuzzy, indigenousic multi L fuzzy, indigenousic multi Q fuzzy, indigenousic multi QL fuzzy, indigenousic multi QTS fuzzy, and then indigenousic multi TS fuzzy, and also interval valued L fuzzy. These are the interval valued stock fuzzy expansions are there. Varieties are this one, and next one is bipolar valued concepts are there, and then these are the algebraic structures we can moving in different type of algebraic structures are there in the format of this one, group, fuzzy group, indigenous fuzzy group, and each and the above type of fuzzy we can form as a group structure, and also ring structure, skew field structure, vector space structure, semi-ring structure, hemi-ring structure, near-ring structure, semi-group structure, monoid structure, abelian groups. These are the many algebraic concepts are there. This is the types of algebraic structures. And last one, thank you. Thank you for your cooperating this type of seminar. And then once again, I express the management for conducting this type of seminar and encouraging this type of seminar for the staff members. I thanks to all of the staff members, particularly the head of the Department of Mathematics, and the all teaching and non-teaching staff members. I thanks to the students, research scholar, or everything. Once again, I thanks to all of you for giving the opportunity to me for presenting the webinar on the webinar sessions. Thank you. Thank you very much.
Thank you very much for your wonderful presentation and shared your knowledge and spared your valuable time with us. Sir, we have a few questions.
Okay.
By Arundhati Nadarajan, you have defined
Okay.
fuzzy subgroup, fuzzy subring. Is there any definition exist for fuzzy group, fuzzy ring, etc., sir?
Yeah, fuzzy group is nothing but the given original set, crisp set is called a fuzzy group. So each and every structure, if you form any fuzzy structure, that fuzzy structure is called the fuzzy group. So the fuzzy subgroup is the generalized one for the fuzzy group. So fuzzy group is nothing but the given crisp structure is called fuzzy group. Suppose we take the group theory. So group is also called as a fuzzy group. And similarly, fuzzy ring.
Sir, next question, the same person, Arundhati Nadarajan. Actually, where fuzzy arises in algebra?
Yeah.
Where fuzzy arises in algebra?
Okay. Generally, the fuzzy arises in naturally the given two-valued logics are there in the given for x2 set interval 0 comma 1s are there. Suppose we want to generalize this concept into the many one, this type of situation we create the fuzzy structures. So same as the algebra is also also depend on the set theory. If you develop the set, automatically the algebra is also developing.
Yeah.
Okay.
Sir, actually, I think if 16th slide by Sivaraman Ramaswamy, F inverse of V is not A. I think our slide is 16th slide. He asked this question, sir.
F inverse of
F inverse of V is not A. Is it right? He's asking.
F inverse of V is not A.
In our 16th slide, sir.
Wait. F inverse of A?
Uh, F
F
inverse
inverse of
of
A?
V. F
A?
inverse of V. F inverse of V is
Hmm.
not A.
Yeah, trivially, if it's not A, this is not
Yeah.
possible.
That's it. Ma'am, next question. For the fuzzy group A of G, the group G need not be a fuzzy. So
For
for
the fuzzy subgroup A of G, the group G need not be a fuzzy.
fuzzy,
So,
is it
yeah,
correct?
need not. This is trivially fuzzy.
It's
This is
trivially
also
fuzzy.
each and every crisp set we can represent it as a fuzzy structure with the help of the characteristic function.
Ma'am, next question. Ma'am. So where a group theory is used? Maybe fuzzy group theory.
So
Where group theory is used?
generally the group theory is used in the chemical structure, particularly in one of the paper in chemistry department. We use the group chemical. So this is I know that group structure is a different type of are used in this one. I know about that particularly this one used in group structures in this chemistry, physics, and anything. If you want any clarification, you go to in chemistry department in separate book or the book name is group chemical group chemical.
Ma'am, is it any question more? Any more questions, ma'am? Yeah, thank you, sir. I think we
Thank you,
complete
Professor.
all the questions. Yeah, thank you very
Thank
much,
you,
sir.
Professor. Thank you, Professor. Thank you,
Mathematics
Professor.
is not about numbers, equations, computations, or algorithms. It is
Yes.
about understanding. By William Paul Thurston. Our next national webinar on the axioms of choice and some of its consequences by Dr. Alladi Sriram, Assistant Professor, AM Jain College, Chennai, on tomorrow 10:30 a.m. to 12 noon. Kindly register the same. We'll meet tomorrow on the next webinar. Today's webinar's feedback form posted in the chat box. Today, we learned new things with the fuzzy. With this enthusiastic mood, I invite Ms. C.M. Subbalakshmi, Assistant Professor, Postgraduate and Research Department of Mathematics, DG Vaishnava College, to deliver formal vote of thanks.
I would like to take this opportunity to place on record on behalf of Postgraduate and Department of Mathematics, DG Vaishnav College, to thank our resource person, Dr. K. Arjunan, for his wonderful talk on role of fuzzy algebra. I also extend my thanks to our beloved secretary, Sri Ashok Kumar Mundraji, for his enormous support, and our respected principal, Dr. R. Ganeshan, for his motivation, and our convener and head of the Department of Mathematics, Professor R. Venkatramanan, for conducting this webinar. An event like this cannot happen overnight. The wheels started rolling weeks ago. We have been fortunate enough to be backed by a dedicated organizing committee, and a heartfelt thanks to our colleagues of our department for their support. Today, I take this opportunity to put all my gratitude in the form of words to all our participants for their enthusiastic participation. I once again thank everyone for making this webinar a successful one. Thank you.